everyone, this is Miss Graham, and today we are going to be looking at lesson 5-2, midpoint on the coordinate plane. Go ahead and pull out your Springboard textbook and have it open to page 56. Our learning targets for today are we going to be using inductive reasoning to determine the midpoint formula, and we're going to use the midpoint formula to find coordinates of a midpoint of a segment on a coordinate plane. We've previously looked at this idea of midpoint last week and this week as well. So we know midpoint is a point on a segment that divides it into two congruent segments. So we know that's two exactly equal segments, and we even went over the congruent symbol last week as well. We're going to follow the steps below to explore this idea of midpoint on the coordinate plane and derive the formula. So let's go ahead and look at this graph right here. So it says in the table below, we're going to write the coordinates of the endpoints of each of these segments, and then we're going to use those to help us find the midpoint. I'm going to use a little color here as I go through each of them. So let's look at segment AB. So we can write the endpoints. Let's start with A. It's going to be 2, positive 2. And for B, it's going to be 2, positive 6. Looking at our next segment, CD, we're going to see that the endpoints for C are going to be 4, 7. And for D, it's going to be 11, 7. For segment EF, I'm going to use green. And we know those endpoints are going to be, for E, it's going to be 4, 1. And F is going to be 6, 5. Last but not least, for segment GH, we're going to have the endpoints for G be 8, 4, and H is going to be 14, 0. Again, remember when we are putting points as the endpoints, we always do X first and then Y. Now, it wants us to use a ruler, but we're kind of just going to eyeball it to figure out what the midpoint is for each of these segments. Most of them, you can easily see it, and I'm going to tell you how I was able to find it. So looking at AB, we can see that there is a point right here that lies in the middle. So that midpoint's coordinates are going to be 2, 4. So that was our vertical line. Let's look at our completely horizontal line, CD. We can see that the coordinate of the midpoint is right there. So those values are going to be 8 and 7. Now starting to transition to some diagonal segments, maybe a positive slope or a negative slope, I can see that the midpoint is right there for EF. So the coordinates are going to be 5, 3. And then we can look at our negative slope segment, GH. So we can see the coordinates for that are 11, 2. So what if we don't always have a graph for this? We're not able to plot any of these points. What do we have to do? Well, maybe let's look at a pattern to see if we notice anything about these midpoints in regards to their endpoints. So looking at question number 2, what I did was I copied the table from question number 1 over so I could look at and compare the x coordinates. So looking at the x coordinates, we can see for every single one of these, it's going to be these highlighted numbers, 2, 4, 4, 8. And for the endpoints, it's going to be 2, 11, 6, 14. Now we have to look at the midpoints, x coordinates. If we first look at segment AB, we can see the x coordinate is the same. So we can go ahead and write that on down. The x's are the same. But if you notice for the rest of them, segments CD, EF, and GH, they're not. But let's try to use some logical reasoning. If we look at EF, we can see that 5 is exactly between the other endpoints as x values, 4 and 6. Well, what if it's a little bit harder to see that, right? What if we're looking at 8 and 14? Maybe the idea that I have for for 4 and 11 from CD is the same as 8 and 14 for GH. Taking all this into consideration, what we could do to find what's in the middle is if we find those measures of 8 and 14, We add them together and divide by however many numbers I'm adding. Remember, that's kind of our average. That's how we could find what our value is. It ends up being 22 divided by 2, which is 11. And guess what? The same thing checks out for segment CD. So that's what we're looking at here. We're finding the average of the x values of our endpoints to get the midpoint. If the number is the same for both endpoints, then we know the midpoint will also be the same number. So let's go ahead and write that below in 2a. So we're going to say if the x values are different for the endpoints, you find the average between them to get the x value for the midpoint. Awesome. And again, remember, if they are the same number for both endpoints, the midpoint will also be the same number. So we're reviewing that idea of average. Remember, average is adding all the numbers together and dividing by 2. For midpoint, we're only working with 2 endpoints. So we're always going to be adding 2 numbers and dividing by 2. What if we did the same thing for our y values? Let's see if we notice a similar pattern. Again, if now I'm looking at 2b, it says compare the y coordinates. Okay, so let's go ahead and do that. Let's look at our y coordinates and see if we notice the same pattern of having the average of the endpoints equal the midpoint. So let's look at AB. So the average of 2 and 6. All right, so you add them together, you get 8. Divide by 2, hey, we get 4. Let's try it again. For CD, hey, we got 7 and 7. Oh, so the midpoint's y value is 7. So this pattern does continue on. We can check it with EF and GH. It'll literally be the exact same thing. So instead of rewriting the whole entire thing, we're going to say this is the same as part A, right? The average of the y coordinates endpoints will be its midpoint y coordinate. So now let's use this pattern that we talked about to now come up with what the formula is for our midpoint. So remember, let's say we generically know x1, y1, and x2, y2. So we talked about how the midpoint will equal the two x values added together, so x1 and x2, and divided by 2. That will yield the x coordinate for our midpoint. So the y coordinate, again, is going to be the y values added together and divided by 2. We want to make sure we have a comma in between and parentheses because this represents a point. Now let's actually practice using this formula on number 4. So number 4 says use the formula we just came up with. Perfect. For the following endpoints. Let's say point A is 1, 4 and point C is 11, 10. So I want you to go ahead and figure out what the midpoint is. Go ahead and pause the video and show your work to use this formula to come up with the x and y value of the midpoint. All right, did you get the following point? 6, 7 included in parentheses? Awesome, good deal. Now there is a follow-up question that it talks about. It says, what can you conclude about segments AM and MC? So maybe we kind of got to visually draw this picture to see what's happening. So we said M is in the middle of A and C, and we know we have to put those congruence tick marks. So it's asking them, what do we know about AM and MC? Well, remember, AM is going to be congruent to MC, right? They're going to have the same size, same length, and we can easily see that from our picture. We're going to go ahead and skip numbers 5 and 6 and turn to number 7. This problem is going to be a little bit different because they don't give us both endpoints. They actually give us an endpoint and a midpoint. So it might be helpful to draw a picture for us here. So we have our line segments, and we're going to have some midpoints. So let's read the problem. It says the midpoint M of ST. It gives us, M has the coordinates 3, 6. And it tells us point S has the coordinates 1, 2. So we have to figure out what the coordinates are for point T, which is really my x2 and y2 value. There's actually a couple ways that we can do this. So I'm going to show you 2 ways to do it. So the first method, as I said, with a number 1 next to it, is to kind of use our formula. So remember, we have the midpoint of x is equal to my x1 plus x2 divided by 2. And we know the midpoint of my y value, right, is equal to y1 plus y2 divided by 2. So we're going to fill in all the pieces we know. We know the x value and the y value of the midpoint. So I can actually substitute 3 and 6 into those equations. And I also know my x1 and my y1. So I can substitute in 1 and 2 into both of those. But I don't know the other missing pieces, my x2 and my y2. So I can leave those in there. And right now I have 2 different equations that I could set up to solve for our missing value. So looking at these, we have to think about what is the best way to start to get these variables, x2 and y2 by themselves. Well, I might want to multiply by 2 on both sides. So I get rid of that dividing by 2. So I'm doing that. So now when I rewrite my equation, I have 6 equals 1 plus x2. And I have 12 equals 2 plus y2. Remember, we multiply these numbers by 2. So that's how I got 6 and 12. Then I also think, okay, what's my next step? What can I do next to isolate my variables? Well, I subtract 1 for this. I subtract 2 for that. So lo and behold, we can see we have 5 equal to my x value of the endpoint. And we have 10 equal to the y value. So I could rewrite that as 5, 10. Now, some of you looking at this might be thinking, whew, that's a lot of algebra. Maybe I want to try to think about this from a pictorial sense, right? So let's go back to our picture and think about this in regards to distances. So let's say we look at the distance from my x value to that x value. How do I get from 1 to 3? Well, I'm adding 2. So guess what? The same thing is going to happen when I go from 3 to 2. I'm going to add 2. So we know for the x value, it's going to be 3 plus 2, which gives me 5. Hey, that checks out with what we got before. We're going to do the same thing with the y values. How do I go from 2 to 6? Well, I add 4. And then I'm going to do the same thing when I go from 6 to my other y value. I'm going to add 4. So for my y2, I'm taking 6 plus 4, and that gives me 10. Hey, that's exactly what I got before. So my coordinates here will be the same. It'll be 5, 10. Both work. Both check out. Again, you can use either one to do it. This second one, the second method, is kind of the visual representation in case you want to use that. It does help to kind of use arrows and maybe make the picture big enough or use different colors. But either way, we saw that we got the endpoints of t. So instead of explaining how we determined our answer, we kind of visually showed it in 2 different ways. When I go, let's go ahead and turn to the bottom of page 58 and find some open space. I think we're pretty good on reviewing midpoints since we have seen it a little bit earlier. I do want to do a little bit of simplifying radicals review of what you just recently saw. All right, I want you to go ahead and write the following 3 problems down: the square root of 8, the square root of 20, and the square root of 40. And I want you to go ahead and simplify each of the radicals. Hopefully that gave you enough time to go through and do each of these. If not, pause the video, have a little bit more time added on. So looking at these, we want to think what's the biggest perfect square number that goes into each. So looking at the square root of 8, we really have the square root of 4. So the square root of 4 times 2, or we can give each of those numbers their own radical. So that way we have 2 square root of 2. Moving on to our second problem. Biggest perfect square number that goes into 20, ironically again, is 4. So I really have the square root of 5 times 4. And I can even give them their own individual square root signs. So the square root of 4 is 2, so we have 2 root 5. Last but not least, let's go to 40. Again, the biggest perfect square number that goes in is 4. Man, I'm targeting the fourths today. So we have the square root of 4 times the square root of 10. Remember, you can give each of the numbers their own radical and reduce to 2 square root of 10. Now, reviewing what you saw last year in Algebra 1, these numbers are the exact way to say these irrational decimal numbers. The decimal approximation is basically some number that goes on and on and on, repeats forever, and has no end. And in fact, instead of saying repeats, it actually has a random kind of number combination. We're going to talk about today how to put these in our calculator, as well as about rounding approximations. It will be helpful to have a graphing calculator on hand as we go through these today. So with your graphing calculator, you actually are going to start by inserting 2 square root of 2 into your calculator. So you can easily find the square root button by looking for the tiny little x squared button along the left side. So the button will kind of look something like this, and then it's going to have a small symbol in the corner that looks like that for the square root. So that means we have to press the second button in the top left corner first, and then hit the x squared button. So make sure you do the first 2, then go through those channels of the square root button, and then you can click 2 underneath it. So when you put that in your calculator, you're going to get some weird decimal. Now, when we have these decimals, what we're going to do is we're going to use these kind of squiggly equal signs to mean that, hey, we're going to round this. Let's say we wanted 2 decimal places, or we wanted to round to the nearest hundredths. When we have 2 square root of 2, it ends up being 2.83. So be careful on when to round and when not to round. In order to determine the 3 that's there, if the third number is 4 or less, we keep it the same. If the third number is 5 or more, we move up that second number. Let's go ahead and try 2 square root of 5. So again, same process as before, put 2 in your calculator, then click the second button, and then the x squared button to get that square root sign, and then type in 5. So go ahead and do that now, and let's see what you get. All right, when we do that, we get around 4.47. So again, make sure you're rounding correctly since we're using 2 decimal places. All right, I want you to try the last one on your own. 2 square root of 10. Type that on in, write down your decimal approximation to 2 decimal places or to the hundredth spot. Pause the video, and then check back with your answer. All right, when you did that, we should have gotten 6.32. So right now, if we keep it in radical form, that's our exact way of writing the answer. When we have it in a decimal, that's called a decimal approximation, and I'm just going to abbreviate that. So it tells us what the number is sort of around, where this exact number tells us exactly what it is. All right, looks like we're onto our homework for tonight. So we are going to actually pull a homework problem from yesterday's lesson as well as today's. So from yesterday's lesson, you're going to turn to page 55 and do number 26. For today's lesson, you're going to look at page 58 and do numbers 12 and 13. I also have them listed here below so you can check to make sure you're doing the correct problems. All right, happy mathing.